Hello students, once again welcome you to GK's maths classes. Today we are going to continue with continuity and differentiability. This is the part 2 of the video where we are going to do problems. Okay. Already in part 1 we have discussed the definition of continuity and various conditions. I will put the video, the link of the video in the description box for your reference. Okay. So now I will not be going inside the concept once again. I will be only solving the problem. Maybe I'll just give you an introduction once again, little bit about what continuity is. So a function f of x is said to be continuous at x is equal to a. When is it continuous? It is continuous when the limit exists. When does the limit exist? When LHL is equal to RHL. And then f of a should exist and both should be equal. So three conditions should be satisfied. Very important that all three conditions are satisfied for the function to be continuous. Okay. Now with that definition, we'll straight away go to the problems. Now I want to find a and b. Here the question is find a and b. And what is given? If the function given there is continuous at x is equal to 4. Okay. So it's already said it's continuous. So when they say it's continuous, that means all the conditions are satisfied. All these conditions are satisfied. Left hand limit exists, right hand limit exists. They are equal to the limit and also equal to the functional value. Okay. Now, to do this problem, first what I will do, I will find out the definition of mod x minus 4. What is definition of mod x minus 4? Modulus of x minus 4 is x minus 4, x greater than or equal to 4, minus of x minus 4, x is less than 4. So this is the definition of modulus of x minus 4. Okay. Now, let's go to left hand limit. I am doing LHL, RHL because there are two different functions to the left side and right side of 4. So what is left hand limit? Limit x approaches to 4 minus. 4 minus means x is less than 4. X is less than 4 means I have to use this function, right? So it is x minus 4 by modulus of x minus 4 plus a, correct? So this is 4 and x is approaching to 4 from the left side. So x is definitely less than 4. Now when x is less than 4, what is definition of mod x minus 4? This is limit x approaches to 4 minus, this is x minus 4 by minus of x minus 4 plus a by the definition of modulus. So this will become a minus 1. So my left hand limit x approaches to 4 minus f of x is a minus. So my left hand limit is a minus 1 and the left hand limit exists because it's given the function is continuous. Now let's go to right hand limit. Now what is right hand limit? Right hand limit is limit x approaches to 4 plus. 4 plus means I am coming to 4 from the right hand side. So the value of x will be greater than 4. So x is definitely greater than 4. So it will be x minus 4 by modulus x minus 4 plus b. I am using this. Okay. So now this is limit x approaches to 4 plus. Now by the definition of modulus, this will be exactly x minus 4. When x is greater than 4, it is x minus 4. So they get cancelled. I get b plus 1. So what is my right hand limit? Limit x approaches to 4 plus f of x is this. Correct? Now what I do, since the function is continuous at x is equal to, I will be using this every time, so I'll just copy it and keep. At x is equal to 4, since the function is continuous at x is equal to 4, what do I know? My LHL, left hand limit, will be equal to right hand limit, will be equal to f of 4. Now what is LHL? LHL is A minus 1, already we have done. What is RHL? RHL is B plus 1. And what is F of 4? F of 4 is given as A plus B. Now what do? You take A minus 1 equal to A plus B and B plus 1 equal to A plus B. So from this you can see clearly B equal to minus 1 and A equal to 1. So when A is 1 and B is minus 1, this function is continuous at x is equal to 4. I hope this is clear. Very simple direct question. Okay. Now let's go to the next question. This is greatest integer function. F of x is greatest integer function. I have to show it's discontinuous at all integral values. Now what is the definition of greatest integer function? Greatest integer function is greatest integer less than or equal to x. Or in simple words, if I want to find the value of 3.987, I ask a question, it lies between which two integers? Definitely 3.987 lie between 4 and 3. It lies between 4 and 3. Take the smaller integer. Which is the smaller one? So it's 3. So this is the definition of greatest integer function. Greatest integer less than or equal to the number. Okay. Now what is the value of, for example, I'll take another one, 135. You know, 0.135 lie between 0 and 1. So the smaller integer is 0. So what is the greatest integer value of minus 2.65? Minus 2.65, okay, lie between minus 3 and minus 2. Minus 2.65. So the lesser integer is minus 3. So all this you have done in class 11th. So I'm not going to repeat it, just for your understanding I've written it. Okay. Now what I will do, I will start with, this is an NCERT question. Okay. Let K be an arbitrary integer. I am taking K as an arbitrary integer. It can take any value. K is an arbitrary integer. Okay. Now, first of all, I'll take left hand limit. I take limit x approaches to K minus f of x. That is, see, this is K. My x is approaching to K from the left hand side. So x is less than K. Okay. So what will be that? Limit x approaches to K minus greatest integer function of x. So when I say my x is approaching to K from the left side, my x value will be between K and K minus 1. It will be between K and K minus 1. It's between K and K minus 1. So what is the lower integer? The lower integer is K minus 1. So the limit is K minus 1. So my left hand limit is K minus 1. Okay. For example, if you take K as 3, if we take K as 3, when x approaches to 3 minus, then the greatest integer value is 2. Okay. Now, right hand limit. Now, what is right hand limit? Limit x approaches to K plus f of x. K plus means x is definitely greater than K. Limit x approaches to K plus. Now, what is K plus? See, look at this. This is K. X is approaching to K from the right hand side. So my value of x will be between K and K plus 1. My x value will be between K and K plus 1. Which is the smaller integer? The smaller integer is K. So my right hand limit is K. Now clearly you can see the left hand limit is not equal to right hand limit. If left hand limit is not equal to right hand limit, what do you say? Limit x approaches to K, f of x does not exist. If the limit does not exist, you can straight away say the function is discontinuous at x is K. But K is what? K is arbitrary. Therefore, the function is discontinuous at all integer values. If it is true for 1k, if it's true for k equal to 1, it will be true for k equal to 2, because k can take any integer, arbitrary integer it is. Okay, so this is a very beautiful proof. Okay, now I'll just show you the graph also. I just want you to see it. Just a second, I should have kept it ready. I'll just show you greatest integer function and we'll analyze the graph. Now here what I will do, it is actually the function name is floor. It is not exactly greatest integer function, there's a small error, but we'll take it for convenience. Okay, so this is the graph of greatest. It is also called step function. You can see this is a step function. Okay, now if you see, at 0 there is a gap, at 1 there is a gap, at 2 there is a gap, at 3 there is a gap. So this greatest integer function is discontinuous at all integer values. So you are able to see it visually. The greatest integer function is discontinuous at all integer values. Okay, now let's go back to our thing. Now the next question is, show that the function greatest integer function is continuous at x is equal to 3 by 2. Okay, it's 3 by 2 is not an integer. Okay, so let's talk about left hand limit. Limit x approaches to 1.5 minus, specifically I take 1.5, 3 by 2 is 1.5, greatest integer function. So this is 1.5. My x is coming to 1.5 from the left hand side. So my value of x will be between 1.5 and 1. So my x will lie between 1 and 1.5. Right? So which is the smallest integer? Which is the first integer you see? It's 1. So your left hand limit is 1. Okay? Let's talk about the right hand limit. Limit x approaches to 1.5 plus greatest integer function. Now this is 1.5, x is coming to 1.5 from the right hand side. So your x values are between which two integers? It's between 1 and 2. Your 1, this is where it is. This is 2 and this is 1. So your x value lie between 1 and 2. So when it is between 1 and 2, which is a smaller integer? The smaller integer is 1. So the right hand limit is also 1. Since LHL equal to RHL, what do you say? Limit x approaches to 3 by 2, f of x exists, and what is that equal to? 1. Just because limit exists, can I say the function is continuous? Definitely no. What I need to verify? I need to verify f of 3 by 2. What is f of 3 by 2? Greatest integer value of 1.5. You know, greatest integer value of 1.5 is 1. So f of 3 by 2 is also 1. Now, clearly you can see limit x approaches to 3 by 2, f of x equal to f of 3 by 2. All the three conditions are satisfied. You can say the function is continuous at x is equal to 3 by 2. So what is the meaning? Just look, let's go back to the graph. When I go back to the graph, you can see clearly between two consecutive integers, between 0 and 1, it's continuous. Between 1 and 2, it's continuous. So 1.5 is somewhere here. See this? This is 1.5, correct? This is 1.5. So when I approach to 1.5 from the left side or from the right side, my limit is always 1. You see this? This is 1. That is why LHL is equal to RHL. Okay? So between two consecutive integers, between n and n plus 1, it's continuous. But at all integer values, it's discontinuous. This is something you should never forget. Okay? So let's go back to this. So you can write a note actually. The note is the greatest integer function is discontinuous at all integer values. Now greatest integer function is continuous between n and n plus 1, where n is an integer. It's continuous in between two consecutive integers, n and n plus 1. Okay, so don't forget this. This is very, very important. Okay, let's go to the next question. This is again discuss continuity of the function. Greatest integer function of 3 minus x. Greatest integer function of 3 minus. It is getting shifted by 3 units. That's all, nothing great. So let's talk about left hand limit. So what is left hand limit? Limit x approaches to 1.5 minus greatest integer function of 3 minus x. Correct? So what will be the value? So for example, if you put 3.5, direct substitution, you get 1.5. Greatest integer value of 1.5 is what? Greatest integer value of 1.5 is 1. So left hand limit is 1. Now let's go to right hand limit. Right hand limit, limit x approaches to 1.5 plus. Now here also what happens? When you put 1.5, you get greatest integer value of 1.5, which is again 1. So LHL equal to RHL. This implies limit x approaches to 3 by 2, f of x exists, and that limit is 1. Now what is f of 3 by 2? F of 3 by 2 is same as 3 minus 1.5, which is greatest integer value of 1.5, which is 1. So clearly limit x approaches to 3 by 2 f of x equal to f of 3 by 2. This implies the function is continuous at x is equal to 3 by 2. Okay, between two consecutive integers, always continuous. Let's see how the graph looks like. Okay, that's always nice, you know. Let's go back to this. Let me make it 3 minus x. Okay, 3 minus x. So this is greatest integer function. Look at it. This is how the graph of 3 minus x looks like. Now he wants to talk about 1.5. So look at this 1.5. This is 1.5. Clearly it's continuous. And you see your limit is 1. So everything can be seen visually. Okay. So left hand limit is 1, right hand limit is 1, functional value is 1, and the function is continuous. And once again, 3 minus x is continuous for all real numbers between two consecutive integers, but it is discontinuous at all integer values. Don't forget that. Now let's go to the next problem. Let's see. Okay. Question. Show that the function f of g of x is given as x minus greatest integer function of x is continuous at all integral values. So what I will do is I will take let k be an arbitrary integer. Okay. Then what I do, I talk about left hand limit. So what is left hand limit? Limit x approaches to k minus x minus greatest integer function of x. Now this is nothing but limit x approaches to k minus of x minus limit x approaches to k minus of greatest integer function of x. Now by direct substitution, this will be k. Now what about this? So when x is approaching to k from the left hand side, my values of x lie between k minus 1 and k, correct? It lies between k minus 1. My x values will lie between k minus 1 and k. So my greatest integer value will be k minus 1, the lower value, right? So when I open the bracket, I get 1. So this is my left hand limit. X minus greatest integer function of x is 1. Now let's go to the right hand limit. What is my right hand limit? This is limit x approaches to k plus x minus greatest integer function of x, which can be written as x approaches to k plus of x minus limit x approaches to k plus of greatest integer function of x. So by direct substitution, you will get k here minus, let's analyze this. I am going to k from the right hand side. So my x values will lie between k and k plus 1. Correct? So which is the lower value? So the lower value will be k. Okay. So greatest integer value will be k. So it is 0. So clearly you can see your right hand limit. Right hand limit is k, is 0. Now what do you know from this? LHL is not equal to RHL when limit does not exist. Limit x approaches to k, f of x or g of x, whatever you call it, g of x does not exist. Since limit does not exist, you can say clearly the function is discontinuous at x is equal to k, since k being arbitrary integer implies for any integral values. Correct? See, the function is discontinuous at k, but k is arbitrary. So that means k can take any value. So it will be discontinuous for any integral value of k. Okay, that is what I want to discuss. Now let us have a look at the graph, how this graph will look like. Now the question is, let's see how it goes. So it is actually x minus, where is it? X minus, it will be floor of, one second, I will type it, x minus floor of x. You can see the graph. Now when you look at the graph very clearly, it's continuous between 0 and 1. It's continuous. You see, it's continuous between 0 and 1. But at 0, it's not continuous. Can you see? At 0, it's not continuous. Right? Your left hand limit will be 0 and your right hand limit will be 1. That is exactly what we got. Your left hand, for every integral values, your left hand limit will be 0 and your right hand limit will be 1. So, and you can see it is discontinuous at all integer values. This is a graph of x minus greatest integer function of x, where the function is continuous between two consecutive integers, but it is discontinuous at all integer values. Okay? So that's another way to analyze, look at it and understand. These graphs help you to understand things better. Okay. Now let's go to the next question. This is a very, very, very important question. E power 1 by x. So when it is e power 1 by x or 2 power 1 by x or a power 1 by x, we use LHL and RHL. So let's see. Left hand limit, watch this carefully. This is limit x approaches to 0 minus. 0 minus means x is definitely not equal to 0. So it is e power 1 by x minus 1 by e power 1 by x plus 1. Okay. Now when x approaches to 0 minus, 1 by x will approach to minus infinity. When x approaches to 0 from the left side, 1 by x will go to minus infinity. This is x is approaching, this is 1 by x. Correct? Now e power 1 by x, if I take exponents on both sides, will approach to e power minus infinity. E power minus infinity is 0. You know e power minus infinity is 0. So now what do? You take this, x approaches to 0 minus e power 1 by x minus 1 by e power 1 by x plus 1, which is e power say minus infinity minus 1 by e power minus infinity plus 1, which is 0 minus 1 by 0 plus 1. So your left hand limit is minus 1. F of x is minus 1. It's better you don't write like this. For your understanding I wrote, don't write e power minus infinity, but you just say when x approaches to 0 minus 1 by x approaches to minus infinity, therefore e power 1 by x goes to 0. Okay. That's the left hand limit. Now let's go to right hand limit. Right hand limit is a little bit, you need to think. Limit x approaches to 0 plus e power 1 by x minus 1 by e power 1 by x plus 1. Please understand, e power minus infinity is 0, but e power infinity is undefined. Okay? This you should not forget. So, when x approaches to 0 from the right side, 1 by x will approach to infinity. Okay? So, when x approaches to 0 from the right side, 1 by x will approach to infinity. So, when 1 by x approaches to infinity, e power 1 by x will approach to infinity, because e power infinity is infinity. E power infinity is infinity. So you get infinity by infinity, which is an indeterminate form. If I do direct substitution like this case, in this case, it will be e power infinity by e power infinity, which is infinity by infinity, which is an indeterminate form. So that is not the right thing to do. So what do? Multiply this by minus. So minus 1 by x will approach to minus infinity. Okay. So e power minus 1 by x will approach to e power minus infinity. E power minus infinity is 0. So somehow I have to create e power 1 by x. How do I do that? I take x approaches to 0 plus. From this I take e power 1 by x out. So what do I get? I will get 1 minus e power minus 1 by x, correct? If I take e power 1 by x, I get 1 by e power 1 by x. 1 by e power 1 by x is e power minus 1 by x. Now from the denominator, I take e power 1 by x. So what do I get? If I take e power 1 by x outside, you get 1 plus, actually you get 1 by e power 1 by x, which is e power minus 1 by x. So they get cancelled. Now you know e power minus 1 by x is 0. You get 1 minus 0 by 1 plus 0, which is 1. Now clearly you can see your right hand limit is 1. What do you say about left hand limit and right hand limit? They are not equal. LHL not equal to RHL. This implies limit x approaches to 0, f of x does not exist. If it does not exist, what do you know? The function is discontinuous at x is equal to 0. Very, very simple. Remember, this is the basic result. You should know this. Okay. Now let's go and see how the graph looks like. First, what I will do, I will delete this. Let me go to this. So it is e to the power 1 divided by x minus 1, sorry, it's not there, minus 1, okay. I should have put this in bracket, I'm sorry, just 1 second. It's in bracket, e to the power of 1 divided by x minus 1 minus 1 go outside, and then divided by e to the power of 1 by x 1 by x plus 1. So you can see the graph. This is the graph. See the graph how it looks. Now look at this. The left hand limit. When x approaches to 0 from the left side, 0 minus. When limit x approaches to 0 minus from the left side, y approaches to minus 1. That is why your left hand limit was minus 1. Can you see it? Now when x approaches to 0 from the right side, when x approaches to 0 from the right side, your f of x approaches to what? It approaches to 1. LHL not equal to RHL. There is a gap which cannot be filled by 1 point. That is what the situation is when LHL is not equal to RHL. Therefore, the function is discontinuous. Where it is discontinuous? At x is equal to 0. So you are able to understand it visually. I hope it's clear. Okay. Now let's go to the next problem. Now find a, b and c for which the function is continuous. It's already given that this function is continuous, and I want to find the value of a, b and c. So let's first take left hand limit. What is left hand limit? Limit x approaches to 0 minus sine of a plus 1 into x plus sine of x divided by x. Actually, this a plus 1 and x is part of the angle. It is not a plus 1 into x. So now what you do, this is limit x approaches to 0 minus sine of a plus 1 into x divided by x plus limit x approaches to 0 minus sine x by x. Okay, so you know limit x approaches to 0, sine x by x is 1. So this will become 1. You know, right? This will be 1. But here you need to do some adjustment. So what do? I will write limit sine of a plus 1 into x. That means I should have also got a plus 1 into x, correct? So I multiply and divide by a plus 1, correct? I multiply numerator by a plus 1 and denominator by a plus 1. And in the limit what I will do, I multiply both sides by x. A 0 into a plus 1 will be 0. So what happens to this? This satisfies the condition of the limit. Sine theta by theta. Here my theta is a plus 1 into x. So here my theta, in this case my theta is x. Since it was x here, I directly wrote it as 1. But here my theta is a plus 1 into x. So I have to make a plus 1. If it is not there, just multiply and divide by a plus 1. So now this satisfies the condition of sine x by x when x approaches to 0 is 1. So since this becomes 1, already you have a plus 1. It will be a plus 1 plus 1, which is a plus 2. So this is your left hand limit. I hope it's clear. This is your left hand limit. Now let's go to right hand limit. What is right hand limit? A right hand limit will be limit x approaches to 0 plus. 0 plus means x is greater than 0. And here it is less than 0. That is why I chose this function. Since it is greater than 0, I will be using the third one. What is that? Root of x plus bx square minus root of x divided by bx power 3 by 2. Okay. Now how do I evaluate this limit? Rationalize. So root of x plus bx square plus root of x divided by root of x plus bx square plus root of x. So when you simplify this, what do you get? A plus b into a minus b will be a square, that is x plus bx square, a square minus b square, divided by b x power 3 by 2 into root of x plus bx square plus root x. So x and x cancels. Now I am going to cancel b. That means definitely I know b cannot be 0. Because if b is 0, this function will not even exist. You see, denominator there is a b. So if b is 0, the function cannot exist. So b can never be 0. Okay. So that is why I am able to cancel it. We should have a reason for everything. Okay. So this is limit x approaches to 0 plus x square by x power 3 by 2 is root x. In the denominator, what I will do, I will take root x common from this. So what do you get? It will be root of 1 plus bx. Correct? I am taking x outside. When you take x outside the root, when I take x outside the root, it will become root x. So this will become 1 and bx square will become bx. Now what is common in the denominator? The common thing in the denominator is root x. You can actually skip this step. Okay? This step can be skipped. Just for your understanding, I am writing 1. So they get cancelled. Put x as 0. You get 1 by, when x is 0, you get root 1. Root 1 is 1. 1 plus 1 is 2. So my RHL is 1. So left hand limit is a plus 1. My RHL is 1 by 2. Okay. Now what I will do? I'll take this. Since the function is continuous, where it is continuous? Since the function is continuous at x is equal to 0, since the function is continuous at x is equal to 0, what do you know? Left hand limit equal to right hand limit equal to f of 0. All are equal. Now what is left hand limit? Left hand limit is a plus 1. What is right hand limit? Right hand limit is half. And what is f of 0? F of 0 is c. So from this you get a equal to, I think I made a mistake here, this is 2, a plus 2, 1 plus 1 is 2. So a equal to minus 3 by 2, c equal to 1 by 2, b, if you look at the left hand limit, your left hand limit is independent of a plus 2. And your right hand limit also independent of b. See, your left hand limit is independent of b. There is no b involved. Your right hand limit also don't involve b because b gets cancelled. And your f of 0 also does not have b. That means b can be, b is any real number except 0. Why should it be except 0? If b is 0, the function is not well defined. Therefore, you have to remove 0. So b is all real numbers except 0. Why? Again, I am repeating. Your LHL is independent of b. Your RHL, even though b is there, it gets cancelled. So b is not at all involved in RHL. And the f of 0 also does not involve b. So b can be any real number. But it cannot be 0 because if it is 0, you cannot cancel. First reason. Or b, if b is 0, this function cannot be well defined. Okay. Now the next question. Very easy and very simple question. Find the value of k if this function is continuous at x is equal to. So it's already given the function is continuous. So first, as usual, we go to our routine, left hand limit. So what is my left hand limit? Limit x approaches to 0 minus. 0 minus means less than 0. Less than 0 means which is the function? It is root of 1 plus kx minus root of 1 minus kx divided by x. Now how to evaluate this limit? Just rationalize. Root of 1 plus kx plus root of 1 minus kx divided by root of 1 plus kx plus root of 1 minus kx. Now this is limit x approaches to 0 minus. So what will happen to this? A minus b into a plus b is a square minus b square. A square minus b square by x into root of 1 plus kx plus root of 1 minus kx. Now if you simplify this, you can see clearly on the numerator 1 will get cancelled and you get 2kx divided by x into root of 1 plus kx plus root of 1 minus kx. X gets cancelled. Now on direct substitution, what do you get? 2k divided by x is 0. So root 1 plus root 1 is 2. So my left hand limit is k. Very simple. Class 11th. Okay? Under the type rationalization. Okay. Now what is RHL? Now RHL, limit x approaches to 0 plus. 0 plus means x is greater than 0. If it is greater than 0, which is the function? 2x plus 1 by x minus 2. Now how do I apply the limit? Do direct substitution. Wherever x is there, put 0. You get minus 1 by 2. You may ask, why can't I do it here directly? When you do direct substitution here, you will get 1 on the numerator. Here also 1. 1 minus 1 is 0. Denominator also 0, indeterminate form. That is why I don't do direct substitution here. I do rationalization and I get rid of that 0 by 0. Okay. I think all that you have studied in 11th standard, so I'm not going into that. Now, since I already have it, so since the function is continuous where at x is equal to 0, since the function is continuous at x is equal to 0, what do you know? LHL equal to RHL. Now what is LHL? LHL is k, RHL is minus half. So I have found the value of k. Right? Simple. Find the value of k if the function is continuous. Now the next question. I slightly changed this question. Actually it is 1 minus cos 4x by x square, x less than 0, 8 when x is equal to 0, root x by root of 16 plus root x minus 4, x is greater than 0. I have to discuss continuity. Okay. Already, but the actual problem was A. I don't know, because that becomes too simple, so I want to do this. So what is left hand limit? My left hand limit is limit x approaches to 0 minus. 0 minus means less than 0. If it is less than 0, I have to use the first function. 1 minus cos 4x by x square. Correct? Now what is the formula for 1 minus cos 4x? 1 minus cos 4x is 2 sine square 2x divided by x square. If the square is not there, suppose let us assume the square is not there. If the square is not there, what I will do? I would have written sine 2x by 2x is 1. Sine 2x by 2x is 1. But since it is sine square, I need to have 2 square. So I multiply by 4 and divide by 4. I multiply and divide by 4. Then what happens? This is limit 2x. I multiply both sides by 2. 2x goes to 0. 2 into sine of 2x by 2x the whole square into 2 square. So this becomes 1 with the limit. So the answer is 8. So my left hand limit is 8. Class 11th. Okay, nothing great. Now go to right hand limit. What is right hand limit? Limit x approaches to 0 plus root x by root of 16 plus root x minus 4. Now I have to rationalize. Multiply and divide by root of 16 plus root x plus 4 divided by root of 16 plus root x plus 4. What happens to the denominator? A plus b into a minus b. If I do that, I will get this root will go 16 plus root x, that is a square, minus b square, correct, into root x into root of 16 plus root x plus 4. Now 16 gets cancelled, root x gets cancelled. Now put x is 0, what do you get? Root 16 is 4, already there's another 4, so it's 8. So what is RHL? Now LHL equal to RHL. If LHL is equal to RHL, what do you say? Limit x approaches to 0, f of x exists. And what is that? It's 8. Now what is f of 0? Very clearly it's given when x is 0, f of 0 is 8. What do you say about both? Limit x approaches to 0, f of x equal to f of 0. This implies the function is continuous at x is equal to 0. Very simple. This implies the function is continuous at x is equal to 0. Okay. Now, one last question. This is our last question. We'll finish this. Now, it's given that the function is continuous in an interval. All this while, we have been talking about point, continuous at a point. Okay. Now, this function is continuous in an interval 0 to infinity. That means it is continuous at all real numbers from 0 to infinity. There are infinite number of numbers, but I am not interested in all the numbers. We are only interested in 1 and root 2. We are only interested in 1 and root 2. Why? That is where you have x less than 1 and you have x greater than 1. Okay. So first let's talk about x is equal to 1. And I'll talk about left hand limit. What is left hand limit? Limit x approaches to 1 minus, what is f of x? X square by a. Apply the limit, direct substitution. This is x is less than 1, right? So it is 1 by a, direct substitution. Now let's go to right hand limit. What is right hand limit? Limit x approaches to 1 plus. 1 plus means greater than 1. Greater than 1 means it is a. This is independent of x, so the right hand limit is a. Now, since the function is continuous, where at x is equal to 1, LHL equal to RHL. Since LHL is equal to RHL, what do you know? 1 by a equal to a square equal to 1, so a equal to plus or minus 1. So let's keep this. So I have found A. Now I need to find B. To find B, I have to talk about root 2. So let's take left hand limit. What is left hand limit? Limit x approaches to root 2 minus. Root 2 minus means less than root 2. If it is less than root 2, it is A. And you know this is independent of x, so left hand limit is A. Now let's go to right hand limit. What is right hand limit? Limit x approaches to root 2 plus. Root 2 plus means what? Greater than root 2. Greater than root 2 means I have to use the third function, which is 2b square minus 4b by x square. Okay. Now substitute. You will get 2b square minus 4b by 2, which is b square minus 2b. Now what do you do? Since the function is continuous, since the function is continuous where at root 2, LHL equal to RHL. Now what is LHL? LHL is A and RHL is b square minus 2b. Now let's take the first situation. When a is minus 1, what happens? B square minus 2b equal to minus 1. B square minus 2b plus 1 equal to 0. This is b minus 1 whole square is 0. Therefore, b equal to 1. So when a is minus 1, my b value is 1. Okay. Now let's talk about a equal to 1. When a is 1, what happens? B square minus 2b is 1. So b square minus 2b minus 1 equal to 0. Now this is a quadratic equation. we can't split the middle term, so I have to use the formula minus b plus or minus root of b square minus 4ac divided by 2a, which is 2 plus or minus root 8 by 2. But root 8 is what? Plus or minus 2 root 2 by 2. So 2 can be cancelled. You get 1 plus or minus root 2. This is your b value. When a equal to 1. So when a is minus 1, b is 1. When a is 1, b will be 1 plus or minus root 2. So with that we finish all the problems, but I thought the previous problem, this alone, I will see whether I can do it on GeoGebra and show you whether it's continuous or not. So we have discussed continuity, right? So 1 minus cos 4x, right? So let's talk about that. Okay. Condition, if x is less than 0, then it is 1 minus cos 4x cos 4x divided by x square. So this is the graph. Now it's working. Okay, f of x is equal to 1 minus cos 4x by x square. Now the next part of the question is, if just one second, if condition x is greater than 0, now what's the function? It's actually root x, it's actually root x divided by root of 16 plus root x minus 4 plus enter. So I got the graph now. Let's zoom out and see. So you can see clearly this is the graph. This graph represents 1 minus cos 4x by x square, whereas this graph represents this, okay, root x by root of, you can just zoom in and see how the graph looks like. Okay, so now clearly you can see the function is continuous. Where it is continuous, when you approach to 0, from the left hand side, it is 8. When you approach to 0 from the right hand side, it is also 8. LHL is equal to RHL, limit exists. So this is another way to understand the limits, through diagram, through GeoGebra. See, left hand limit is 8, right hand limit is 8, function is continuous. I hope you have understood and enjoyed this, and this GeoGebra helps you to understand the graph clearly. Okay, I hope this is clear. We will continue with more problems in the next class. Kindly subscribe to my channel and also click the bell icon to get notifications. Have a wonderful day. See you. Bye-bye. Thank you.